Hello and welcome. It's a huge pleasure for me to be on the stage today. My presentation will be a bit different than the others maybe you have seen, because I'm more from the media industry and from the entertainment industry, and we create camera systems and really work with data. And I'm very pleased to be at this great lineup today. And a lot of things from the theoretical parts, like Bob Chen has showed earlier today, like all the amount of data saving and copy times, really comes down in our studio as well when we do those captures with high resolution data. And we really rely on those data because this makes our workflow faster. But maybe I give you like a little introduction, who I am, what we're doing, and a bit of the data afterwards. But I'm not so much focusing on those parts today because all the other presentations take so much good coverage about that. So my name is Sven Bliedung von der Heide. You can call me just Sven. And I have a strong background in the movie industry. So I have worked on several feature films like Avengers, Cloud Atlas. I did a lot of visual effects on those movies. And as mentioned, this presentation is maybe a bit different. But to kick it off, maybe we start with a short little trailer to get you a glimpse about what we are doing. And basically, all the humans you have seen in those trailers are not like normal 2D video camera captures, but all 3D humans. So they all be captured with our technology and placed in other different 3D environments. And this is like the big thing we are focused on. Because you can imagine the whole movie industry is in a very, very huge shift. So we're moving from 2D to 3D, which means everything gets scanned in a 3D environment. And as you can imagine, having like rooms scanned is maybe something that we have already like 10 years. But if you have actors inside of the room and you want to capture an environment, a movie set with the actor in motion at the same time, it's a complete different way of capturing movies. And especially when you look at newer devices as well, like mixed reality headsets and all those new kind of display technologies, where you really need 3D content because you can't show it with a normal 2D camera anymore or capture it with a normal 2D camera. Yeah, and one of the big challenges actually are humans. As you can imagine, you may be all aware of something called motion capture, where people getting like in those suits where they have a lot of balls on the body and then they try to capture those motions. And this is the technology which is on the market since quite a long time now. And when you look at those game characters, you already have, I think, seen some computer games. Even if they're based on real people or persons, they never look really realistic. And this is a very huge challenge or a very big issue that you can't usually create real humans in a real-time environment. And the other way, you have the big movie industry who just put a lot of money and effort into it, where like hundreds of artists working on just one person to create just one single shot of a person you see here on the side with Stallone, to just create very short sequences. And in the end, in the audience, you still see that something doesn't look real or something doesn't feel real. And this is something that we looked into how we can overcome. And basically how we do it. So what you see here is our volumetric capture studio. And this is basically just a room where we have a lot of cameras and we can just capture like on a movie set, and then afterwards we have a complete 3D representation of the person. So the person you see on the left is the real camera footage from the studio, and on the right is the 3D representation. And if you compare it with the traditional workflow, so on the left side you see our studio, and on the right side the normal way how you create those avatars or those persons. As mentioned earlier, there are like hundreds of people usually involved into it, and for us it's a completely automated process. And that's why it's a complete game changer in how we create content for the movie industries nowadays. And if you compare it, this is now for real time from a game engine actually, with a AAA title like Cyberpunk. The whole character creation process is completely different. It's way faster, it's way cheaper, and it's not so much intensive in terms of labor. And that's one of the reasons why it's really a complete disruptive technology, what has been evolved here in our studio grounds. So it's a new way of creating content. And we are actually, to get to this point, we're actually creating our own cameras. So this is one of the things that we have done to get to this point. We're building our own cameras at a very high resolution. And there are a few competitors on the market, but we are by far the leading one, actually, when it comes to resolution and quality. So this is just a comparison of digital humans. Basically, this is one from our competitors to our quality, and you see how much quality makes a big difference in getting really like the close-up situations of a person. So what we are doing with those technology, where we use it, actually, we have created all the camera systems for Matrix Resurrections, basically the last installment from Lana Wachowski. And as you can imagine, this is the normal default case. We have our studio, we have the actor inside of the studio. So we just do the quick capture of the actor, and the beauty is afterwards we have the actor fully in 3D. So this is Ellen Holland, famous actor in the Matrix suit with her jump. As you maybe know, this key element from the older movies as well. And this is now the full 3D representation of her after the capture. And it really took like 10 minutes to do the quick capture of her, and then we have the data, it's processing, and then it's a complete 3D person, actually. And we can place her anywhere in every situation in the movie and reuse her over and over again for all those scenes. And yeah, this is part of the beauty. Therefore, we're creating a lot of different camera systems. So we're not shooting only in our environment. We're also building a lot of different systems we bring into the sets, even doing like underwater volumetric capture. And as mentioned earlier, we're really capturing the whole set with the actors, with the environment, and everything with motion. And this is really like the game-changing part of it, even like doing completely underwater volumetric video, where we build all underwater housings on our own cabling and everything from scratch to do volumetric underwater capture. This is how it looks in the end, basically, when all the processing have been done and the characters have been replaced by our 3D doubles, actually. And I just skipped through some of the slides. This is to visualize you the challenges just of a face. If you look just purely at a face, there's so much motion going on, and that's why it's so challenging to recreate faces of persons by normal human labor work, basically, because you have so much motion going on, and with this process, it's completely automated. And it's not just ending there, actually. We are able to add new motions into the faces, to let actors and people act differently, to let them speak new things that they haven't been spoken, and change basically the persons. We can also use those 3D captures of the humans in all kind of different environments, so they adapting to light and everything when we change out the environments. And this is basically really the domain what we are working on, what is changing so drastically, that we're now capturing humans for every big production. And it's also something like a insurance for the production. So if the actors get sick or something, they just can replace them way easier afterwards, or can use them for different shows. Another use case, for example, famous musicians from Germany, we just did a capture, and then you can take out your iPhone or your smartphone, you can take videos with them, and you can share it on social media. And this is like the beauty, you can walk around them, so there are a lot of applications. It's not just movie industry, it's basically all kind of industries. We use them for replacing extras in the background for movies, like characters in the background, you can just place them and you save a lot of money, basically instead of casting a lot of people. Just for that, we have, for example, created a whole catalog where we sell humans online now as digital assets, basically. It's a stock system, so you can really just shop the humans there now, like $100 per person. And when you have usually a lot of architects using it right now, so if you have a scene, you just place them in there, and then the whole scene becomes vivid and more realistic, because then it's populated with not just those 2D things of humans, but really like 3D representations. Of course, this comes with a huge challenge. And the huge challenge is how we handle those amount of data. I mean, you can imagine it's good to have camera arrays and everything is automated, but you need to automate it and you need to have very fast delivery times. And as mentioned before, the resolution is very high, so it's like 6,000 times of 4K resolution, actually. And it's not something small, as you can imagine, what we're doing there. And we're really pushing the boundaries. I mean, the reason for that is that our clients really demand those extremely high resolution of face close-ups and of those fidelity of the actors. And we have more than 40 cameras actually shooting from all the angles, even sometimes more than 100 cameras per shot. And this is quite crazy what we're doing. Just to give you like idea what this resolution means, just to get you a brief glimpse. So, I mean, you're all aware of full HD resolution, which is the normal thing that everyone is streaming usually at home. When we zoom further out, then we have this 4K resolution. Basically, when it gets smaller, when we zoom further out, we have 8K resolution, which is already like 4 times more than 4K. And if we zoom further out, this is one of our cameras. This is just a resolution from one of our cameras, actually. And we don't capture like compressed raw signals, compressed signals. We really capture the uncompressed raw signals from the camera, which means we have all the data available, which means that this data amount is way bigger than any normal 8K camera would even create. And if you zoom further out, we have like, this is the setup of our old studio from last year. So we have for one frame already like a lot of data. And if you zoom even further out, this is our current stage. So we're now shooting with more than 3,000 pixels per frame in uncompressed raw signals. And this is a lot of data. I can promise you that. And the beauty is that actually last year together with Huawei, we really evaluated and tested the whole data processing pipeline and got hardware to really play around with that. Because you can imagine when we did a capture, it took us like 18 hours from a day to just download the capture data to a very fast storage system. And this means that we will lose a full day basically of production because we have to wait a full day and then we can shoot only the 2 days afterwards actually of this data. So we introduced, or Huawei actually introduced the OceanStar Pacific to our system. We integrated into the pipeline, and this really changed a lot in terms of bandwidth and compression and downloading times. So with this, we reached actually 18 gigabyte per second of bandwidth, which means that we really drastically lowered the copy time, which actually end up in the end that we could copy in just 2 hours the whole data. So we could do like now a lunch break, basically copy down or download all the data, and we could even on the same day do a complete fill up of our spaces again. So we can utilize our storage is basically way faster than we could actually before. And this is, I think, a very nice, I would say, real use case where we really measured it and we really need to use it and really trusted on it, and it really worked out in the end. And this was something that really impressed us because it showed that all those numbers that have been shown before really come up in the practical, real way when you really implement those systems. Yeah, and then one part that is also very, common nowadays is like stuff like deepfakes. As you can imagine, we're also doing now a lot of replacements of face actors and so on. This is something that comes in more and more publicly available sometimes, but also in the movie industry, it's like the standard. So what you see here is the camera rig, which we have created specifically just for deepfake captures. So we bring them on the set, we can capture the actor, and we have now, here's an example. Basically, this is like 2 different faces blended with each other. So on the top left, you see Trinity from the Matrix. On the top right, it's basically the character Bugs, and they're blending between them. So we swap out the faces, and we can mix different personalities and different actors now with each other. But the challenge for those systems is that you need to have a reliable way to capture all the required angles of the face and all the different kind of light situations that you can guarantee that you can create a very high-resolution deepfake. Because we all know those low-end deepfakes from the internet, but if you want to bring it on a cinema screen for a close-up, you need to overcome a lot of different challenges, as you can imagine. And for that, we actually created something together with Warner Bros. We call it the gold standard for deepfakes now, because it's a very lightweight camera system we bring into the set. And after 10 minutes of capture with the actor, we have like the guarantee that we can reuse this actor for face replacements, as you can imagine, like stuntmen that get replaced the face. Here's one of the deepfakes in action. This is actually a deepfake we applied onto volumetric capture. So you see a bit of the effect on it. So on the top left, you see the 3D model of the person, and the other one is the model with the textures. And we can even mix and match those deepfake things onto the 3D characters. And as you see it, it still looks quite realistic actually. And this is, if you add a bit more post, then you can integrate them into any kind of 3D environments. One thing that is now pushing even further, because I mentioned that the movie industry is moving from 2D to 3D. Actually, now the next step is actually the whole movie industry is moving to AI. And this is another very drastic shift. And I could imagine, like in the next 3 to 4 years, actually, we will see a lot of feature film products or projects coming up where no humans actually have been involved anymore. where basically the actors, the stories, everything get written by AI and get rendered by AI. And we started in 2020 already on the product metrics. For this image, what you see here, this is fully rendered by an AI. And we got all the information. So what we did here, we captured the actors, we captured the environment, and we trained it into a machine learning system. And we could make it in a way that we can even like slow down the time a lot, and we can change camera angles. And this is what the shot came out basically afterwards. So what you see here is fully trained and rendered by an AI. There's no meshes or no real camera work involved into it anymore. And this is something that I personally see as a very shifting or very drastically changing factor of the whole entertainment industry. And I think this will relate not just to the entertainment industry, but to all the other industries as well, that we will basically now start. I mean, before, if you want to create such a shot, it took like a whole camera department, a whole team, and a lot of effort into doing that. Now in the near future, it will be possible to create it basically just by simple text prompts, or even like those text prompts get automatically generated and everything is basically rendered. And this will come to a point where basically the human will be a slowing down factor in the whole movie production pipeline. And the question for us, for example, is really as a company, how do we fit actually into those environments where actually all your staff, all your crew, all the brain power you have in your team basically competes with the algorithm, and you can't really compete with it anymore. And this is the journey we started about a half a year ago, that we actually changed our whole structure. I mean, for the next 2 or 3 years, we will work a lot in the movie and games industry, but apart from those elements or those time of span, I think everything will be more going into an AI-generated environment. And from this point, we are focusing more now into actually capturing high-resolution data for training such systems. Because as all those technologies will become more higher in terms of resolution and better and flexible, they need higher resolution of data. As you can imagine, having, for example, a robot doing surgeries, those robots need to have a lot of high-resolution training data from actual surgeries, how to hold a scalpel or something like that to do those surgeries, and those training data is not available yet. So we will more and more focus now actually in creating those high-resolution training data of hands and everything that we can use for training robots and training basically artificial intelligence for the next generation of replacement of human brains basically by AI systems. And this is something what we're now developing and towards through. So I think this development of the whole entertainment industry into AI also relates to all the other industries, and it's quite challenging thing or task that every company will have to overcome over the next few years. And it's quite an interesting journey. And I would love to be here in the next years also to see how maybe the audience will change or how the strategy will change, because right now I think most of the people don't really want to think about those topics yet, but they're already like very close to us, and it will be quite interesting over the next years to see that development coming. Yeah, with that, I'm very, very happy to be here on the stage. There's my LinkedIn account. If you have any question or you want to get in touch with us, just drop me a message. I'm very happy about that. And to this point, we do a lot of, also, I mean, you can imagine with this technology, we often have like management or CEO people or from HR departments just coming to our studio. We do a quick capture. Afterwards, they have themselves as 3D representations, and then people in the company or for advertisement, you can just scan a QR code, and then you see the person on your smartphone in 3D standing in front of you, and they're doing the presentation. So all those digital, every time basically where you want to have a digital representation of a human, there's basically only the way of doing motion capture, which is expensive, or really doing volumetric video. And if you want to have a real representation, volumetric video is actually the only way to go for it, to have a real representation which looks natural and is not extensively expensive. So thank you very much for your attention, and hopefully this is a bit like a different style a bit, and thank you very much.